Good morning everyone. This is Dr. Srimanta, Assistant Professor in Chemistry, Department of Science and Humanities, MLR Institute of Technology, Hyderabad. Today we are going to start a new chapter called Polymeric Materials. So here basically today is the first lecture. So here we are going to learn what is polymer, and after that we are going to learn why we will study polymer, and then classification of polymer. There will be lots of classifications, so we will learn all those things. So now question is, what is polymer? So polymer, basically poly means many and mer it means monomers. So it basically means lots of monomers. Now what is monomer? Monomer means single molecule. For example, ethylene CH211CH2. This is one monomer molecule. Now just imagine lots of monomer molecules like this. If they link together, then that will become one single unit, means single chain, and that is called polymer. Polymer means where lots of monomer molecules are linking together and building a huge molecular weight molecule. So in simple words we can say polymer means this is macromolecules, and where all the small molecules called monomers, those will be linking together and form this kind of huge molecule, macromolecule. And molecular mass of polymer, it can range from 5,000 to 2 lakh gram per mole. Means one mole of this polymer, it has molecular weight from 5,000 to 2 lakh gram. So now question is, why we will study polymers? So if you look at this characteristics of polymer: low density, good corrosion resistance, good moldability, economical means cheaper, can be produced transparent and with a different color. So it basically means we can replace metal in different areas. That's why, because of this characteristics property, packaging, textile, automotive parts, medical devices, electronics, construction, consumer goods, adhesive and sealants, aerospace, sports equipment, everywhere we're using polymers. Basically we are replacing metal with polymers. So why we will study polymer? So basically it has lots of applications, so that's why every engineer should learn this thing. Now the question is classification polymer. How we will classify polymer? So here you can just see lot of diagrams, lot of actually classification techniques. So basically how we will understand this thing? Just imagine in a classroom 100 students are there. Now we can classify those students based on their genders, male or female, or we can classify them based on their heights or skin color or religion or some based on location. So those 100 students, they are fixed, but based on different parameter we are classifying them. In the same way we have limited or lots of polymer. Based on different parameters we are going to classify polymers. For example, if we consider origin or source, based on origin or source we can classify polymers like natural polymers, semi-synthetic polymer and synthetic polymer. So example of natural polymer is starch or cellulose or protein. So these are all natural polymers. Natural polymer means which is directly, we can get those polymers from nature directly. Now come to synthetic polymer. Synthetic polymer means we can synthesize those polymers in lab. For example, polyethylene, polyvinyl chloride. So these are totally we can synthesize this kind of polymer in lab. But what happens if we have natural polymer like cellulose and we introduce some functional group like nitro? Means we have natural polymer, we are incorporating one functional group to that natural polymer, so it will become semi-synthetic polymer. So example is nitrocellulose. So based on origin, so we have three types of polymer: natural polymer, semi-synthetic polymer and synthetic polymer. Now based on structure, polymers can be classified in three sections: linear polymer, branch chain polymer and cross-linked polymer. So how the structure will look like? For example, if you consider linear polymer, the structure will be like this. There will be just chain. Okay. Now if you consider branched chain polymer, in that case, each and every chain, they will have lot of branches like this. Okay. If you consider cross-linked polymers, in that case, if for example here you can see two different chains, they are connecting. Okay. Here also these two chains, they are connecting together. So basically cross-link means if you consider parallel 3 to 4 chains, they are connecting together. Branch means only branches will be there. Linear means only simple linear chains will be there. So that's why based on structure we have linear, branch and cross-linked polymers. So now based on molecular forces, based on molecular forces we have elastomers, fibers, thermoplastic and thermosetting polymer. In the separate, we have separate slide based on this thing, we will discuss later. Now based on mode of polymerization. So polymerization means how polymers are being synthesized. That particular method is called polymerization. So based on mode of polymerization, polymers can be classified generally in two types, addition polymers and condensation polymers. Now there is another type of classification, that is based on nature of monomers. So here what happens, if you consider single type of monomer, for example this AAAA, so these are the same monomer units but same monomer multiple units. If they form polymer, so that will be called homopolymers. So the condition for homopolymers is identical monomers. There must be identical monomers. So what happens if we change one monomer unit, for example AB like this, or A B C A C B like this. So more than one type of monomer if present, in that case that will be called copolymers. So in case of copolymers, at least two different types of monomer unit must be there. Okay. So based on nature of monomers, we have two different types, homopolymers and copolymers. Now there is another type of classification, that is based on tacticity. So tacticity based classification, what happens if you see these structures, polystyrene, we have polystyrene. So here one phenyl ring is there, SAGE to bond SAGE, this ring, this is polystyrene unit. Now if all these ring positioned in the same side, for example you can see this structure, so all the phenyl ring, those belongs to the same side. In this case we will call this polymer, this structure or this isomers is isotactic. Iso means same, so all the phenyl rings, those belongs to the same side, so this is isotactic. Next, syndiotactic. So here if you say alternate arrangement of phenyl ring, alternate arrangement, if there is alternate arrangement of phenyl ring, in that case we will call that polymer or that particular structure or isomer is syndiotactic. But if this ring positioned randomly, there is no separate rule, same side or alternate side, there is no rule, randomly if they positioned, then we will call it atactic polymers. So this is based on tacticity, this is the classification based on tacticity. So here we have three different types, isotactic, syndiotactic and atactic. Now classification of polymers based on molecular forces, as you have seen here. So already we have seen based on monomers, based on molecular forces, we have elastomer, fibers, thermoplastic and thermosetting. So let's discuss that one. So elastomers. So what kind of molecular forces is there? So here very weak van der Waals force and sometimes hydrogen bond. These two bonds or this kind of molecular forces are present in case of elastomers. And from the name itself, you can just think elastomer means elastic. You can just expand, compress, okay. So soft, elastic, it can return to its original shape. So example, natural rubber, neoprene, like this. Fiber, so here strong hydrogen bonds, dipole bond, all these things are there. These are all molecular forces. These are present in case of fibers. So here the characteristics is high tensile strength, low elasticity. Low elasticity means you cannot expand and compress easily. Example, nylon, polyester, okay. Then come to thermoplastic. So thermoplastic means here intermediate van der Waals force will be there and dipole molecular force will be there. So again, if you consider thermosetting polymer, here covalent bonds in cross-linked network is present. So covalent bond is present in case of thermosetting polymer. So now if you think, if you just compare thermoplastic and thermosetting, in case of thermoplastic, the molecular force are weak as compared to thermosetting, because in case of thermosetting, covalent bond is present. So if you compare characteristics, thermoplastic polymer can be melted, okay, multiple times. You can just recycle this polymer multiple times. It has very high flexibility. But if you consider thermosetting polymer, in that case, it is very hard, brittle, and you cannot recycle this. The main difference between thermoplastic and thermosetting is thermoplastic polymer, you can recycle that polymer. But in case of thermosetting polymer, you cannot recycle that. Example, thermoplastic. So here example is polyethylene, polypropylene, and in case of thermosetting polymer, bakelite, epoxy resin, phenol formaldehyde resin. So all these things are thermosetting polymer. So in this lecture, what we have learned, we have got the idea of polymer, how we will call something as polymer. So that thing we have understood. Then why we will study polymer. So there are lot of good characteristics property over metal. So that's why we can use polymers in various applications, various fields. So that's why we have to learn as engineers, each and every student should learn polymers. Then various types of classification we have learned based on source, origin or source, then molecular force, then various other polymerization techniques. So based on all those things, we have classified polymers. So this is the end of this class. Thank you.